years, Tesla has built a unique communication strategy, consistently camouflaging new models before their official launch. Whenever a Tesla test car hits the road, it's usually wrapped in heavy disguise, making it nearly impossible for outsiders to recognize the real design. This sense of mystery has sparked intense curiosity among tech and car enthusiasts, fueling endless speculation, analysis, and debates across social media. Every leaked photo, every shaky video clip is scrutinized in detail as people try to imagine the shape, lines, and even the design philosophy behind the vehicle. Tesla seems to understand the psychology of anticipation all too well. Ambiguity creates expectation, and expectation generates massive media buzz without the company having to spend much on advertising. Cars like the Model 3, Model Y, and more recently the Cybercab have all followed this formula. Only when the official reveal event takes place do we finally get to see the full design and details, reminding us that all prior speculation was, at best, just guesswork. And over the past months, a smaller vehicle than the Model Y has repeatedly been spotted under camouflage, and this is indeed the Model 2. The affordable car that Elon Musk confirmed has been in production since June. However, aside from being more compact than the Model Y, none of us really knows what lies beneath those layers of disguise. That's why the latest leak is such a rare and valuable glimpse, revealing a small portion of the car's true design. Yes, the Model 2 has once again been seen testing around the Fremont area, but this time its front end was left uncovered, with only the rear section still hidden. As expected, Elon Musk has maintained Tesla's signature design language for the Model 2, featuring slimmer LED headlights compared to the Model Y, while still delivering a cohesive, modern look. The low-sloping hood, smooth curved surfaces, and complete removal of a traditional grille highlight Tesla's continued focus on aerodynamics, reducing drag to maximize battery efficiency. The wheels also appear to follow the familiar design seen across Tesla's EV lineup. Overall, the Model 2 is about 20% smaller than the Model Y, confirming that it's truly a compact crossover, just as earlier reports suggested. Most importantly, the Model 2 will indeed have 4 doors instead of 2, a point that has been debated for quite some time. The flush door handles are similar to those on the Model Y, while the rear remains camouflaged, leaving us unsure of what changes Tesla might have made there. Some speculate the rear light bar may have been removed on this model. Very possible, though we'll need to wait for more leaks to know for sure. So what do you think of this design? Does it live up to your expectations? The fact that the Model 2's front end is no longer camouflaged may actually be part of a new Tesla strategy, meant to prove that the car is indeed in production and really will launch by the end of this year. Specifically, the Model 2 is set to make its official debut at the Tesla shareholder event, the company's biggest event of the year. Looking back at Tesla's product timeline, the company almost always unveils a major headline-grabbing product toward the end of the year, and the Model 2 is widely expected to be the centerpiece this November. To be clear, this isn't a completely new design. The Model 2 still shares many lines and features with the Model Y. That may very well be a deliberate move by Tesla to counter its Chinese rivals, especially BYD. And let's face it, we all know the Model Y is Tesla's most balanced vehicle, and its most successful SUV to date. Tesla owes much of its current dominance to the Model Y. That's exactly why copying a proven formula but slashing the price by as much as 60% is Musk's strategy with the Model 2. He isn't reinventing the wheel, he's simply putting the car on the same production line as the Model Y while stripping away costly features and design elements to hit that $15,990 price point. These adjustments and simplifications are a huge factor in how Tesla manages to keep costs so low with the Model 2, though some buyers may be less than thrilled with the trade-offs. For example, the Model 2 will almost certainly use fabric seats, which are less comfortable and harder to clean compared to Tesla's vegan leather. The removal of the panoramic glass roof will make the cabin feel tighter and less airy. Single-pane acoustic glass will mean less sound insulation. The basic single-color ambient lighting will give the interior a less premium feel, and fewer speakers will make music and movies sound less immersive. At the end of the day, if you want premium features and a richer driving experience, you'll want to stick with the Model Y or Model 3. The Model 2 simply isn't designed for that, and it could be disappointing if you expect it to deliver the same experience as sitting inside a Model Y. That's just the reality. As you can see from the Model 2 images, it doesn't look exactly like the Model Y, but the spirit of the Model Y is clearly there, since both vehicles are essentially built on the same production line. While design is only a small piece of the overall curiosity surrounding the Model 2, another hot debate is whether this will be Tesla's least powerful car. Many argue that with a price tag under $20,000, the Tesla Model 2 will inevitably come with major performance compromises. But what if this car still manages nearly 300 miles of range and a 0 to 60 miles per hour time of around 7 seconds? That's what's expected. In reality, EV prices are falling fast thanks to larger production scales and cheaper battery technology. Tesla has been leading the way in using cost-efficient battery innovations and maximizing the efficiency of its gigapress machines, cutting thousands of dollars off production costs per vehicle without sacrificing too much performance. And while the world still assumes Tesla is focused only on improving lithium-ion batteries, Elon Musk is rumored to be working on something far bolder, replacing lithium entirely with aluminum-ion batteries, a technology that promises to be faster, cheaper, and safer. The surprise twist? The very first car that could be equipped with this new battery might not be the high-end Model S or Model X, but the Model 2 itself. Previously, we fully believed that the Model 2 would use LFP batteries for this car, since Tesla has traditionally chosen LFP cells for the lower-cost versions of the Model 3 and Model Y. This is a balanced solution between cost and durability, and it's also the common choice among many Chinese automakers. However, when aiming to sell the Model 2 at just $15,990, cheaper than many small ICE cars, LFP may still present a price barrier. Even though it's cheaper than NMC or NCA cells, LFP still might not be enough to give Tesla a decisive advantage against the fierce competition from BYD and other Chinese EV makers. As a result, Tesla is reportedly considering an alternative, a battery that's even cheaper than LFP while offering significantly better performance. According to leaks said to come from insiders and reported by the media, this new battery will completely replace lithium, the aluminum-ion battery. When this news broke, we were quite surprised, since ever since its founding, every battery Tesla has used has contained lithium. In recent years, the company has begun using lower lithium chemistries like NCA and NMC, but it has never fully eliminated lithium. That's why the Model 2 may end up being the first car to test this new battery technology. In terms of energy density, aluminum-ion battery prototypes have already shown the potential to reach 450 watt-hours per kilogram, double the energy density of most current lithium batteries, which tend to plateau around 200 watt-hours per kilogram. This means aluminum-ion batteries are capable of storing twice the energy of lithium-ion batteries per unit of weight, resulting in improved performance and longer lifespan. And guess what? That allows Tesla to build a lighter battery pack, perfectly suited for the Model 2, a compact vehicle designed with weight efficiency in mind to maximize overall performance. While we'll have to wait until November for the official launch and full specifications, current leaks suggest the car will deliver at least 300 miles of range, thanks to aluminum-ion cells, aerodynamic design, and a lighter structure. Instead of carrying a large 60 kilowatt-hours or 75 kilowatt-hours pack like the Model Y, the Model 2 will use a 53 kilowatt-hours battery, significantly smaller, but entirely reasonable for a more affordable vehicle. Of course, the higher energy density of aluminum batteries helps make up for the smaller pack size. Naturally, there will be two different variants. The Model 2 long range is expected to offer even greater driving distance, at a slightly higher price, catering to customers who prioritize extended range without frequent charging. And as we mentioned earlier, aluminum-ion batteries are actually even cheaper than today's LFP cells, a major advantage that makes them an ideal choice for the Model 2. In fact, a 53 kilowatt-hour aluminum-ion pack is estimated to cost about $2,000 less than an equivalent LFP pack. The reason is simple. Aluminum is far more abundant than lithium, nearly 1,000 times more common in the Earth's crust. If you're skeptical, feel free to look it up on Google, ChatGPT, or even Grok. We're confident you'll find the same results. As a prediction, we suspect Tesla will most likely equip the new model with just a single motor. History shows that whenever Tesla removes one motor from its dual-motor all-wheel drive versions, the vehicle's price typically drops by about $3,000 to $5,000. However, that figure doesn't simply reflect the cost of a motor alone. In reality, as we said earlier, Tesla often trims additional features at the same time, such as reducing the number of speakers, removing heated seats, cutting rear entertainment screens, or swapping out double-glass windows to further lower overall costs. The key point is that Tesla announced 2 years ago that it was developing a new electric motor with a production cost of only $1,000. Since then, almost no updates have been given, but if there's any model suitable to test and commercialize this technology, it would undoubtedly be the Model 2. On top of that, during a meeting a few months ago, Tesla confirmed it was developing a motor using ferrite magnets instead of rare earth magnets, which are both expensive and tied to geopolitically sensitive supply chains. If true, this could be part of the same project. Of course, switching to a lower-cost motor might result in reduced power compared to Tesla's current lineup. While we don't know the exact production cost of existing motors, many sources estimate around $2,000 each. If that estimate is accurate, adopting a ferrite motor priced at $1,000 would save Tesla about $1,000 per car, an absolutely critical factor in making the $15,990 price point for the Model 2 a reality. This is exactly how Tesla can deliver a low-cost car while still maintaining decent performance. Remember, the Model 3 standard range, even as the entry-level version, still offers acceleration and range that outclass many rivals in its price bracket. With the Model 2, the clear goal isn't to turn it into a supercar, but rather a practical city vehicle, still agile enough for highway driving and efficient for daily commutes. If Tesla were to release a weak, underwhelming model, it would be nothing short of self-sabotage after more than a decade of building its reputation. A common question is whether the Model 2 will come with full self-driving capabilities. We can confidently say yes. Previously, the camouflaged Model 2 prototype that was spotted already featured a front bumper camera, and honestly, this doesn't come as much of a surprise. During Tesla's Q2 earnings call, Elon Musk hinted that this model would indeed support full self-driving, just like Tesla's other vehicles. This is clearly part of Tesla's strategy. They won't strip away FSD hardware just to save a few $1,000s. While the Model 2 may not include every premium feature found in higher-end Teslas, keeping the FSD hardware makes perfect sense, since many Model 2 owners may want to use their cars for robo-taxi service when they're not driving them personally. A low-cost car is Tesla's ticket to expanding its market share. It's clear to everyone. Current models like the Model 3 and Model Y remain relatively expensive compared to what many consumers can afford. Meanwhile, Chinese competitors, especially BYD, are already selling EVs for as little as $10,000 to $12,000. If Tesla doesn't respond, the risk of losing ground in emerging markets is significant. But the big question is, will this budget car make buyers turn away from the Model 3 and Model Y? The answer may be more complex than it seems. The new model will be designed with many cost-cutting changes, and it certainly won't feel as premium as the Model 3 or Model Y. It will be the slowest Tesla, with a 0 to 60 miles per hour time of around 7 seconds and a top speed capped at 112 miles per hour. The interior will be stripped down, perhaps even a bit cheap and noisier. And while its range may reach 300 miles, some customers will still demand more. Yet this is precisely Tesla's smart strategy. A budget car will attract buyers who never even considered owning a Tesla because of the price barrier. When they walk into a showroom looking for a Tesla under $20,000, they'll get to experience the difference firsthand. And we believe a significant portion of those buyers will be willing to spend an extra $20,000 to upgrade to a Model 3 or Model Y, with its more luxurious interior, longer range, and stronger performance. In other words, the budget model won't cannibalize Tesla's existing sales. If anything, it could boost them through the upsell effect. Beyond that, the budget model reinforces Tesla's core mission, bringing EVs closer to everyone. Elon Musk has long emphasized that Tesla isn't just about making luxury cars, but about accelerating the transition to sustainable energy. And this year, with the arrival of a budget model, Tesla may be closer than ever to turning that vision into reality. In short, a low-cost Tesla this year isn't just another new product. It's a key strategy to expand market share, attract new customers, drive upsells to higher-end models, and strengthen Tesla's position as a global EV pioneer. Tesla's continued secrecy around the Model 2 is easy to understand. This approach not only keeps public attention alive for longer, but also reinforces the brand's image as one defined by surprise and disruption. Fans aren't just waiting for a new car, they're waiting for a show, where the curtain lifts to reveal something with the excitement of a work of art being unveiled for the first time. What do you think about this car? Do you think the Model 2 will directly compete with affordable Chinese EVs like BYD? Despite the price barrier, the Tesla bot Optimus is undoubtedly the world's best-selling humanoid robot and a complete game-changer for Tesla. This is because it's the only robot that can make a sandwich in just 10 minutes. while others are still focusing on silly acrobatics, boxing, and falling over. Oh my God, and do you know what this means? You won't have to wake up early every morning to make breakfast anymore. Optimus will prepare and serve it to you right in bed. You won't even need to clean up because the Tesla bot will tidy the kitchen immediately afterward. Yeah, a robot that can cook was something we never dared to dream of. It seemed so far-fetched considering most of them still move like Joe Biden. But Elon Musk has truly achieved a major breakthrough for the Tesla bot through new trials. Optimus will be sold in small quantities next year, and the Gen 3 version will be unveiled this November at 2025 Tesla shareholder meeting. Okay, so, how will a robot cook? How will it distinguish items and understand recipes? Why did Tesla prioritize cooking ability for the Optimus robot? We think you'll want to order this robot as soon as you finish watching this video. Discover the Tesla bot now.
Because I think everyone, of the 8 billion people of Earth, I think everyone's going to want their Optimus buddy. And there's going to be maybe 2.
Imagine if every family in the world owned at least one Optimus. What do you think would happen? Elon Musk has stated that 80% of Tesla's future revenue will come from humanoid robots, which he believes will generate trillions of dollars and ultimately push Tesla's stock price to trade at more than 200 times earnings. This, in a way, affirms the confidence of Tesla's CEO. However, to be honest, for decades when people talked about robots and artificial intelligence, most often they pictured science fiction. Robots that can walk, talk, and serve meals. All of this seemed to exist only in Hollywood movies like iRobot or in far-off futuristic fantasies. In fact, for the majority of the public, the idea of a machine standing in the kitchen, slicing tomatoes, spreading mayonnaise on bread, and serving up a fresh hot sandwich sounds nothing short of absurd. They believe cooking requires subtlety, sensory perception, and the dexterity of human hands, qualities that even the most advanced machines struggle to replicate. From that perspective, robots may replace humans in factories and assembly lines, but preparing breakfast? That sounds downright ridiculous. Yet, what once seemed impossible has unexpectedly become reality. In its recent efforts to expand the tasks and refine the skills of Optimus, Tesla stunned the world by revealing that Optimus Gen 3 successfully prepared a sandwich in just 10 minutes. This marks one of the major achievements at the Tesla bot training facility in Fremont, where the robot has undergone a year-long training process, progressing from simple to increasingly complex tasks. Previously, we had seen Tesla bot perform a series of useful actions in demo videos, but what has actually taken place inside the training facility is far more astonishing. Oh my God, while we've seen many automated cooking machines before, never has there been any news about a humanoid robot being able to cook or prepare food. Clearly, Optimus is beginning to blur the line between science fiction and reality. And from that moment, a series of questions immediately arose. How does a robot cook? How does it know what's a tomato and what's cheese? And more importantly, why does Tesla consider cooking one of the top skills to develop for Optimus? To understand the significance of this event, we first need to realize that cooking isn't just a sequence of simple mechanical actions. It's a combination of perception, dexterity, logic, and a subtle coordination of the senses. When making a sandwich, a chef has to open the fridge, distinguish between ingredients, cut vegetables with just the right amount of force, spread sauce evenly, place layers of meat, vegetables, eggs, and cheese in balance, and finally close the sandwich neatly. It may sound simple, but in reality, every step requires a high level of precision. Even children just learning to make sandwiches can end up dropping ingredients, crushing vegetables, or cutting uneven slices of bread. Yet according to reports, the Tesla bot was able to complete the entire process and finish a sandwich in just 10 minutes. Clearly a technological leap forward. According to what we know, Optimus relies on many different techniques to make a sandwich. But 3 core technologies play a decisive role in this breakthrough: computer vision, dexterous robotic hands, and self-learning artificial intelligence. With its advanced cameras and 3D sensors, Optimus can see the world much like a human. It doesn't just recognize an egg or a slice of cheese. It also understands the spatial relationships between objects in the kitchen. It knows which item is a knife for cutting, which is a jar of sauce, and which is a piece of lettuce that needs to go between 2 slices of bread. This information is processed instantly and sent to its AI brain, enabling the robot to make precise, step-by-step decisions. As we've emphasized many times in earlier episodes, the 22 degree of freedom hand of the Tesla bot is the real revolution, and it's this hand that sets it apart from its competitors. Humans have 27 finger joints, along with a complex system of tendons and muscles, allowing us to both grip a baseball and thread a tiny needle with precision. Tesla has replicated this biological mechanism and applied it to Optimus's hands, with dozens of actuators packed into each one. All you really need to know is that it's far more mind-blowing than most people imagine. Elon Musk himself admitted that Tesla invested enormous amounts of money, time, and effort to achieve it. Thanks to this hand, the robot can delicately hold an egg without dropping it, slice a tomato into thin pieces without crushing it, and spread mayonnaise with just the right pressure. This is something most other robotics companies still fail at. They've built machines that can run and jump, but not peel an orange.
It might be close to half of all the engineering in Optimus. From an electromechanical standpoint, the hand is probably roughly half of the engineering.
But so much of the intelligence of humans goes into what we do with our hands.
Yeah.
The third point, and also the key to Optimus achieving the impressive speed of 10 minutes per sandwich, is its ability to learn through simulation. As we mentioned earlier, over the past year, Optimus has been trained in the factory using videos of humans at work, quickly feeding that data into what Elon Musk calls its real brain.
If Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing, then you really have task extensibility that is dramatic, because then it can learn anything very quickly. And Tesla has some important missing ingredients that others don't have, which is our robot has a real brain. It's like the Wizard of Oz.
The Tesla bot may have been trained using instructional videos on how to make a sandwich, or by observing humans performing the task, then recreating the process in a virtual environment. While integrating the data, the robot likely had to repeat the process many times, making mistakes, learning from them, and refining its actions until it reached the highest level of accuracy. Once the skill was perfected, it was then transferred into the real world. Thanks to this mechanism, Optimus doesn't need to be programmed step by step like traditional robots, yet it can still cook a variety of dishes. This is precisely what analysts see as one of Tesla Bot's biggest strengths. As soon as a user says, "Optimus, make me a BBQ sandwich," the robot immediately analyzes the command, retrieves data, and organizes it according to its training. This flexibility allows the robot not just to repeat a pre-programmed process, but also to be creative and adapt to circumstances, a trait typically characteristic of humans. However, what truly interests the tech world is why Tesla is prioritizing the development of cooking capabilities. Elon Musk once stated, "A useful robot doesn't just know how to walk or carry things, it needs to be able to care for human life." Cooking is the gateway for robots to enter the human world. It's the most basic need for billions of families and simultaneously the most comprehensive test for all the skills of a humanoid robot. Once a robot can prepare breakfast, it implicitly can also clean the house, care for the elderly, or assist in raising small children. The moment Optimus places the sandwich on the plate also holds symbolic value. It transforms the robot from an industrial tool into a companion in the home. Instead of just existing in factories, robots are now standing in the kitchen, a place intimately linked to emotional life and daily activities. That image completely changes how humans perceive robots, which were once seen as terminators.
I'm hopefully ready for Optimus to be used outside of Tesla-controlled environment, or maybe around the middle of next year, second half of next year sometime. So that's, I think that sounds about right. Probably second half of next year is when they'll be available. And then we will offer Optimus robots first to Tesla employees.
Tesla will begin selling the Optimus robot in the second quarter of next year, with the first units delivered to Tesla employees. This follows the company's long-standing tradition of ensuring products are free of critical issues before reaching outside customers. After all, you can imagine how much worse the consequences would be if a humanoid robot malfunctioned compared to a faulty electric car. The risk is far greater, since AI is much harder to control and could potentially be hacked at any time. Since the debut of Optimus, and especially after the release of Gen 2 and Gen 2.5, Elon Musk has consistently emphasized the usefulness of this humanoid robot. Given the wide range of tasks it can perform, the demand for Optimus could be limitless. Cleaning, mowing the lawn, cooking, caring for pets, assisting the elderly, tutoring children, and countless other household jobs. However, Musk has never mentioned the idea of the Tesla bot generating income for its owners, as that would spark controversy over whether it might replace human jobs. Some people fear that robots will replace chefs in restaurants, waiters, or even millions of other low-skill workers. They imagine a future where humans lose jobs en masse while robots take over every corner of society. But history has shown that every technological revolution comes with similar fears. When ATMs were first introduced, many believed bank tellers would lose their jobs. In reality, the number of bank branches actually increased. The reason was that technology lowered costs, which in turn created new opportunities. With Optimus, a similar scenario could play out. New professions could emerge, such as robot trainers, behavior programmers, system supervisors, and maintenance specialists. Over time, humans may gradually shift away from manual labor toward jobs that require creativity and intelligence. The fear that humanoid robots will steal human jobs is unnecessary. Advances in artificial intelligence and robotics are happening at breakneck speed, opening the door for humanoid robots to take on increasingly complex roles across a wide range of industries. With its ability to work tirelessly, the Tesla bot could be leased out as a robotic worker, taking on factory shifts, handling logistics, cleaning, caregiving, and countless other tasks, all while generating a steady stream of income. If its price is under $20,000 and it can earn around $1,000 per month, a single Tesla bot could pay for itself in just 2 years and continue generating profit well into the future. Looking further ahead, we believe the Tesla bot could also be deployed in healthcare facilities, hospitals, nursing homes, and other professional environments, even though Musk hasn't publicly addressed this possibility. In our view, introducing a robot like Optimus into such settings could bring enormous benefits. Imagine, for instance, a hospital in California or New York in the near future, where every patient room has an Optimus robot serving as an assistant nurse. Tesla bot wouldn't just deliver meals or administer medications on time. It could also help patients sit up, take blood pressure readings, and even detect early warning signs of health issues through its AI and sensor systems. Clearly, this could mark a turning point capable of transforming the global healthcare industry, don't you think? If you agree, let us know in the comments below. One benefit Elon Musk hasn't revealed yet is Optimus's potential to enhance security for homes, stores, or any area requiring surveillance. It may sound a bit far-fetched, but imagine being able to purchase a Tesla bot and train it to act as a security guard or bodyguard. With its 2ID cameras and 360-degree sensors, Optimus can monitor its surroundings and detect movement in every direction. It could also recognize faces, track suspicious behavior, and respond promptly. When connected to a smart home system, Optimus could lock doors, close gates, cut power in hazardous areas, or even guide the elderly and children to safety in emergency situations. Clearly, this isn't just wishful thinking, right? Thanks to rapid advances in sensors, cameras, image processing, and deep learning algorithms, this vision is no longer out of reach. In healthcare environments where precision and consistency are critical, a robot like Optimus could even outperform humans in routine tasks, especially those where fatigue or stress often leads to human error. The price of the premium Tesla bot may end up being one of the most hotly debated points. Our estimate for the Optimus Gen 3, the high-end version, could reach as much as $80,000. While that figure is far from small and may limit accessibility for many consumers, considering the technology packed into this version and to the long-term vision of what a humanoid robot can bring, we believe it's hardly something worth disputing. Tesla has invested billions of dollars into the research and development of the Tesla bot, particularly in creating dexterous hands, advanced artificial intelligence, and state-of-the-art sensor systems that enable the robot to perform complex tasks. This is far from a simple project like manufacturing cars or consumer electronics. Tesla is facing extraordinarily high costs in developing an entirely new kind of product.
Almost everything in Optimus is new. There's not like an existing supply chain for the motors, gearboxes, electronics, actuators, really anything almost anything in the Optimus, apart from the AI for Tesla, the Tesla AI computer, which is the same as the one in the car.
The premium version of Optimus will come equipped with technologies like Grok Voice, an OLED display, a refined design, a 22-degree of freedom hand, a 4680 battery, and a range of other high-end components. So it's understandable that the cost would be higher. However, when you pay more for a robot with greater functionality and intelligence, It also means it can pay for itself more quickly compared to other Optimus versions. You see the logic here, right?
I mean, ultimately, I think we'll be making tens of millions of robots a year type of thing. It's like serious volume. Maybe 100 million robots a year. It's wild.
And as Elon Musk has explained, Tesla may start with a limited production run, meaning initial manufacturing costs will be much higher than mass production. But once Tesla ramps up to large-scale production, around 1 million Optimus units per year, starting in 2030, the price of the robot could drop to $50,000 or even $30,000. The $80,000 price tag for the premium version of the Tesla bot may seem shocking at first, but when viewed in terms of its long-term potential, it represents a reasonable investment. With its ability to cut labor costs, generate steady income, and take over a wide range of tasks, the Tesla bot will usher in a new era in how we work and live. While it may be expensive today, as technology advances, Optimus is likely to become an indispensable part of both households and businesses in the future. From a social perspective, the impact would be enormous if every family had an Optimus capable of cooking. Parents would have more time to spend with their children instead of being tied up in the kitchen. Elderly people living alone would receive better care. People with disabilities could live more independently with a robot companion preparing daily meals. Even the food industry could be transformed. Restaurants might use robots to ensure consistency and hygiene, while humans focus on creating innovative new menus. So, do you want a Tesla bot? How do you think Tesla bot will handle cooking tasks in the kitchen? Lithium batteries are basically everywhere in our homes these days, in all our electronics, our phones, everything we use. But more impressively, over 95% of EVs around the world right now are powered by lithium-ion batteries. Oh wow, that number alone shows just how dominant lithium still is as the gold standard in battery tech, with very few alternatives coming close to replacing it. But here's the thing. Lithium-ion batteries haven't really made any major breakthroughs in years. Their energy density hasn't gone up much, while the costs and fire risks haven't gone down either. That kinda explains why EVs still haven't fully won people over, partly because they're still expensive, and the safety concerns haven't exactly gone away. Even though Tesla has led the charge in lithium battery tech, and that's a big part of why the company is where it is today with lithium prices soaring, even Elon Musk has had to admit.
So the price of lithium and all the raw materials and the battery cells went crazy. It doubled. The price of cells doubled. Price of lithium, I think, went up at almost like fivefold or 500%. Went up crazy numbers.
So it looks like lithium might not be Elon Musk's long-term bet after all. Because recently, word got out from Tesla's most secretive lab that something new has emerged. Something that could completely disrupt the lithium battery empire. Yeah, a totally new type of battery. This new battery uses materials that are way more abundant, and yet it delivers 3 times the energy density of lithium batteries. Now, we're not saying it's perfect. Every battery has at least one drawback, but across the board, this one completely outperforms lithium. And when that one last drawback is finally solved, this battery doesn't just compete with lithium, it destroys it. So what is this new battery? What makes it so appealing to Elon Musk? And just how powerful is it really? We've looked into it and we're about to reveal everything right now. As we mentioned, Tesla's current position is partly thanks to lithium batteries. The company has used LFP and NMC batteries for the Model 3 and Model Y, and the 4680 battery for the Cybertruck. All 3 types contain lithium, and even nickel and cobalt. If you search on Google, or anywhere else, you'll see that these are very expensive materials, likely among the most costly components used in batteries. Even Elon Musk has admitted that the current 4680 battery is actually more expensive than other types because it contains all 3 materials, nickel, cobalt, and lithium.
Currently, our 4680s cost more than our suppliers.
It must be acknowledged that Tesla's 4680 battery is one of the best batteries available today. However, there's a bit of irony here because in our view, a great battery that's only used in an expensive car is somewhat disappointing. Right now, the 4680 is only being used in the Cybertruck. and even the cheapest version starts at $69,990. This has led many to question, with a sense of skepticism, whether Tesla will be able to use this battery in more mainstream models like the Model 3 and Model Y, at least at some point in the future. We're not so sure because lithium prices are still rising, and with such high costs, that seems almost impossible. Clearly, Tesla still relies heavily on lithium for most of its current battery types, and that's one of the main reasons the company hasn't been able to launch an affordable car. Although Elon Musk has mentioned plans to release a compact EV priced at around $25,000, that goal has been delayed for over 4 years. That's why recent leaks from Tesla's research and development division are drawing attention. Reportedly, the company is testing a new type of battery that doesn't use lithium. Yeah, a first-generation aluminum-ion battery, known by the familiar name A1 battery. Simply put, aluminum-ion batteries use aluminum ions as charge carriers instead of lithium ions, as found in lithium-ion batteries. An aluminum-ion battery consists of 3 main components: the anode, usually made of metallic aluminum, which supplies the aluminum ions; the cathode, made from materials like graphene, graphite, or metal oxide compounds, which stores the aluminum ions; and the electrolyte, a liquid solution that conducts aluminum ions between the anode and cathode. To make it even clearer, aluminum-ion batteries pack a bigger punch because each aluminum ion carries 3 positive charges, compared to just 1 for lithium ions. That means aluminum can shuttle 3 times the energy per ion, boosting energy density without relying on rare materials or fancy engineering. In theory, aluminum-ion batteries can store way more energy in the same amount of material compared to lithium-ion batteries. This explains why aluminum-ion batteries have a density that's about 3 times higher than most lithium-ion batteries today. Reports claim Tesla's aluminum-ion battery has hit over 700 watt-hours per kilogram in real-world tests. That's way crazier than we thought, because if you put a 700 watt-hour per kilogram battery into a Tesla or any similar electric vehicle, the range could easily top 700 miles, if not push toward 1,000 miles. How's that possible? Now, to put it simply, the current Tesla Model 3 long-range AWD has a range of 346 miles with a 79 kilowatt-hour NMC battery. The energy density of NMC batteries is around 180 to 200 watt-hours per kilogram. Now, compare that to aluminum-ion batteries, which have an energy density of 700 watt-hours per kilogram, about 3.5 times higher. If you swapped the Model 3 AWD's battery for an aluminum-ion one of the same size, the range could hit around 1,038 miles. However, we should note that while aluminum-ion batteries hit 700 watt-hours per kilogram at the cell level, the energy density drops a bit at the pack level due to components like the casing and cooling system. With a battery this energy dense, shrinking the pack size is key to cutting costs significantly. So instead of over 1,000 miles, a range of 767 miles is much more realistic. Despite being widely used, as we mentioned at the start of the video, lithium-ion batteries haven't seen any major breakthroughs in recent years, especially when it comes to energy density. Lithium-ion batteries have been stuck at an energy density of about 250 watt-hours per kilogram for decades, and even with Tesla's most aggressive improvements to the 4680 battery, they've only reached 272 watt-hours per kilogram. Of course, energy density isn't the only factor driving Tesla to pursue aluminum-ion battery technology. As Elon Musk has pointed out, a bigger issue lies in the skyrocketing cost of lithium batteries. The price of lithium batteries is rising mainly due to surging demand, while supply remains constrained. This clearly shows that lithium is being overexploited and is becoming increasingly scarce, driving up costs and putting manufacturers like Tesla in a tough spot.
Challenge on that front, then there may be a shortage of lithium.
When Elon Musk decides to invest in new battery technology, performance and energy density are always top priorities. However, what's crucial is that even a high-performance battery, if too expensive and only applicable to luxury vehicles, ultimately fails to have a broad impact. Therefore, aluminum-ion batteries must not only ensure performance, but also address the issue of production costs. Aluminum-ion batteries need to be significantly cheaper than the lithium-ion batteries Tesla currently uses. Otherwise, they won't help Tesla achieve its goal of bringing affordable EVs to the mass market. Of course, Tesla isn't a company that easily discloses pricing details, and to this day they've never publicly revealed the actual cost of the batteries they use. However, it's still possible to estimate that the battery pack typically accounts for about 25 to 40% of the total production cost of a Tesla vehicle, depending on the battery type, variant, and specific configuration. For example, the Tesla Model Y, which ranges in price from $45,000 to $60,000 and uses batteries with capacities between 67 to 82 kilowatt hours, is estimated to have a battery pack cost between $9,300 to $11,400 based on an average NMC battery price of around $139 per kilowatt hour. This means the battery cost makes up about 19 to 25% of the vehicle's total price. Aluminum, on the other hand, is the most abundant metal in the Earth's crust, making up about 8.13% of its total weight. Bauxite, the ore used to produce aluminum, is widely distributed across dozens of countries. With a massive global reserve of up to 1.59 billion tons, aluminum is far more accessible and much less affected by geopolitical risks or supply chain disruptions. This gives Tesla a real opportunity to achieve ultra-low costs per aluminum-ion battery cell. Based on the information we've gathered, the cost of aluminum-ion batteries is expected to be significantly lower, with estimates ranging from $40 to $65 per kilowatt hour once the technology is fully developed. This cost could decrease further with large-scale production. In contrast, lithium battery production costs range from $80 to $145 per kilowatt hour, not including the expenses for costly materials like nickel or cobalt. To put it simply, if the battery for a Tesla Model Y currently costs between $9,300 and $11,400, switching to aluminum-ion batteries could reduce that cost to approximately $4,300 to $5,300. This change alone would significantly lower the overall production cost of a Model Y. Lithium prices have fluctuated sharply over the past 2 years, sometimes dropping but often spiking dramatically. As Elon Musk has pointed out, lithium prices have surged by as much as 500%. In 2024, the average price of lithium carbonate was about $8,200 per ton, and by February this year, it had risen to $9,271 per ton. This is due to global reserves of only about 89 million tons, nearly 18 times less abundant than aluminum. The situation is worsened by the geographic concentration of lithium. Most reserves are found in just 4 countries, with China holding about 16.5%, and the rest primarily in the lithium triangle of Chile, Bolivia, and Argentina. In short, aluminum is abundant and inexpensive, requiring no expensive materials. No lithium, no cobalt, no nickel. Just aluminum, graphite, and a suitable electrolyte. Meanwhile, lithium is becoming increasingly scarce, driving up costs. Aluminum-ion battery technology is ushering in a breakthrough in charging speed that lithium-ion batteries cannot match. While lithium batteries have achieved impressive advancements, allowing an 80% charge in 25 to 35 minutes, aluminum-ion batteries can fully charge in just 15 minutes without encountering temperature issues, a major drawback for lithium batteries. This capability stems from aluminum ions moving through the electrolyte 3 times faster than lithium ions, accelerating the charging process without compromising performance. Moreover, aluminum-ion batteries offer superior thermal management, effectively addressing the temperature issues that frequently complicate and reduce the lifespan of lithium batteries during charging. Thanks to this technology, aluminum-ion batteries not only enable faster charging, but also ensure greater safety and long-term durability. While lithium-ion batteries typically last around 2,000 charge cycles before dropping to 80% capacity, equivalent to about 3 to 5 years of daily use, some independent studies indicate that aluminum-ion batteries can achieve up to 15,000 cycles. This means aluminum-ion batteries could last up to 30 years if properly maintained. This is a significant improvement over current battery technologies, opening up promising prospects for longevity and durability. One reason aluminum-ion batteries can achieve such an extended lifespan is that aluminum is a highly durable material, widely used in modern car frames. Chemically, aluminum is also more stable than lithium. Unlike lithium, which readily reacts with oxygen and water, Aluminum forms a natural oxide layer when exposed to the environment. This oxide layer acts as a protective barrier, preventing corrosion and degradation of the anode material, thus extending battery life. Additionally, the issue of dendrite formation, a major cause of performance degradation in lithium-ion batteries, is virtually non-existent in aluminum-ion batteries. Dendrites are metallic crystals that form during charging, damaging the battery's structure and causing serious issues like reduced performance or even fires. In aluminum-ion batteries, the release of aluminum ions is more uniform and stable, minimizing dendrite formation. Research from renowned institutions like Stanford also shows that aluminum batteries can endure tens of thousands of charge and discharge cycles without this issue, offering significantly longer lifespans than current lithium-ion batteries. Beyond lifespan, another serious issue with lithium-ion batteries is the risk of fire and explosion. Lithium batteries can ignite when impacted or overcharged, and the smoke from burning lithium is highly toxic and extremely difficult to extinguish. Despite years of development and improvements, safety advancements remain minimal. With aluminum-ion batteries, this fire and explosion risk is virtually eliminated due to their high stability and ability to withstand hazardous incidents during use. This is a critical factor making aluminum-ion batteries a safer and more sustainable choice for the future of EVs. Another significant advantage of aluminum-ion batteries is their high recyclability. Aluminum is one of the most abundant materials on Earth, and if aluminum-ion battery technology is widely adopted, it could address environmental challenges related to mining rare earth metals and recycling current batteries. Studies show that up to 80% of aluminum fluoride salts can be recovered in laboratory experiments, with projections suggesting even higher recovery rates at industrial scale. Moreover, solid aluminum foil can be easily reused after cleaning, making the design of aluminum-ion batteries highly conducive to recycling and environmentally friendly. However, while aluminum-ion batteries hold the potential to revolutionize the electric vehicle industry, not just for Tesla but for the entire sector, it's important to acknowledge that any new technology faces challenges and limitations. One significant issue with aluminum-ion batteries is their reduced performance in low temperatures, which limits their usability in harsh, cold climates. This is a critical factor that researchers are actively working to address to enhance the technology's practical applications. Aluminum-ion batteries have not been widely publicized, and they receive relatively little attention. However, based on these findings, if Tesla's A1 battery cells can be mass-produced and integrated into more affordable vehicle models, they could truly be a game-changer. Tesla plans to manufacture these batteries entirely in the United States at a newly expanded facility adjacent to Giga, Nevada. The production line is expected to begin operations by the end of this year, once all equipment is fully installed and calibrated. In theory, aluminum-ion batteries could last an exceptionally long time. Of course, no battery lasts forever, but the question is, how long can they endure? With a potential for 15,000 charge cycles, they are an ideal solution for energy storage, possibly lasting 30 years or more. And the cost? It appears highly competitive. Researchers suggest that mass-producing such a battery pack could cost the same or less than current LFP battery packs. Range anxiety remains a key concern for many EV consumers, especially for long-distance travel. A Tesla capable of traveling 700 miles on a single charge would completely eliminate this worry, offering unprecedented freedom and convenience. When Tesla achieves this range, it will not only produce an EV that rivals gas-powered cars in terms of range, but also position EVs as the primary choice for long-distance travel. If Tesla can address the low-temperature performance issue of aluminum-ion batteries, this technology could become a game-changing breakthrough, fundamentally transforming the electric vehicle industry. Currently, aluminum-ion batteries have demonstrated superior potential with rapid charging, long lifespan, and up to 80% recyclability, which reduces costs and benefits the environment. However, their poor performance in low temperatures remains a significant hurdle for widespread adoption, particularly in cold climates. Once this challenge is overcome, aluminum-ion batteries could not only give Tesla a competitive edge, but also become the cornerstone of its affordable EV strategy. Tesla might be the first to integrate these batteries into mass-market models like the Model 3 and Model Y, reshaping how consumers perceive EVs. What do you think about this? We hope this video got you hyped about the future of batteries and Tesla. If you're feeling the vibe, smash that like button and join the fam by subscribing. Don't forget to hit the bell so you never miss our epic content. Drop your thoughts in the comments. We love hearing from you. Thanks for tuning in, stay awesome, and we'll catch you in the next one.